Okay, so today what we've got to do is talk about what's called a binomial probability. And what this is going to do is let us calculate some probabilities that are very, very difficult to calculate using what we've learned so far. And so what we first need to understand is what a binomial experiment is. Today we're probably not going to talk about where the formula comes from, but if we want to do that tomorrow, we certainly can. And we're going to talk about how we use the formula for a binomial experiment to calculate these probabilities. So, for the first thing I'm going to do here, let's just take a think back to, skipping over something here. First of all, what is a binomial experiment? And so the root word of the binomial experiment is the word bi, which means two. And so a binomial experiment, the big key here is that we can only have two outcomes. So the classic example here is what happens when we flip a coin. We can either get a heads or a tails. We also have things like drug trials where we consider something either a success or a failure. And so in general, what we want to happen, we consider a success, and the thing we're not concerned about, we consider a failure. Now, we can also consider some other things binomial experiments as long as we're willing to limit ourselves to the case where something either happens or it doesn't. And so, for example, if I asked you what the probability of rolling a 4 on a dice is, you could consider that a binomial probability. It's either we rolled a 4 or we didn't. Now, those things aren't equally likely, but the binomial probability equation lets us deal with that because we know the probability of rolling a 4 just once. So let's just take a quick look at one example. This is from your homework from Friday, and this is where we flipped a coin 4 different times, and we were looking at questions like, well, how many ways are there to get a heads all 4 times? Well, that one was pretty easy because there's only one way to get a heads 4 times. You have to get all heads, and there's 16 total ways. But when we looked at things like how many ways are there to get at least 3 heads, or how many ways are there to get 2 or more heads, that got a little tricky. And about the only way we could come up with was just to start listing out all the possibilities. And a lot of you figured out pretty quickly that that is not so much fun to do. Because there are 16 options. And it gets a little tedious to list them all out and try to count up the number of ways you can get at least 2 heads. And so that probability is a little bit hard to calculate the way we know how to do it. And that's where probability distribution or binomial probability comes into play. It gives us a formula for calculating something like that exactly. So, like I said, we're not going to look at where the formula comes from today. It's a little bit beyond what I want to do in a 15-minute video or under 15-minute video. But if you want to come back tomorrow and look at that, we certainly can. So for right now, here's the formula for binomial probability. And so this is a lot to look at here. So let's just go ahead and take a look at everything in here. It's not all that complicated once you understand what everything says. So this is the probability of an event A happening. So that could be like the probability of getting a heads. We're looking at that event happening a certain number of times R in a certain number of trials. So if I was asking you what's the probability of getting a heads 3 times in 4 attempts, we'd use this formula. N would be 4, R would be 3. So what this starts out with is NCR, or as your book puts it, C of N comma R. Again, the other way to write that would be NCR. And so that's the number of ways that you can choose, R things given N things. And so if we were looking at our example of flipping a coin 4 times and getting 3 heads, that's the number of ways you could get 3 heads out of 4 attempts, which is, again, a much nicer way of figuring that out than having to count them all. The next up is the probability that it happens, which is given by P of A, raised to the number of times it happens. So in our case, the probability of getting a heads is 50%, 0.5. We want it to happen 3 times, so 0.5 to the 3. And then this, you've never seen this before, this is the probability that A does not happen. That's what that little bar across the top means. The probability of A not happening. And it is raised to the number of times you don't want it to happen. So in our case, N was 4, R was 3, and so we want this to get a tails, or in other words, not a heads, just 1 time. From there, it's not so bad. You just type that into your calculator, and it'll spit out an answer for you. So let's go ahead and we're just going to do, I think I got 4 examples here. The first few are to do with dice, and the nice thing about dice is that because the probability of getting a 1 is not 50%, it kind of helps us see exactly what we want to see. So calculate the probability of rolling a dice 10 times and getting a 1, exactly 4 of them. And so basically what we're calculating is the probability of getting 4 1s. And so according to our formula, that's going to be the combination 10 choose 4. Then we have to multiply by the probability of getting a 1 raised to the 4th power. And so the probability of getting a 1 is 1/6 to the 4th. Then we multiply by the probability of not getting a 1, which is 5/6 to the rest of it, so 6th power. A couple of things you'll notice. These two numbers here, the 4 and the 6, always have to add up to the number of times they're rolling. So 10 choose 4, 1/6 to the 4th times 5/6 to the 6th. And we just have to type that all into our calculator. And so what we can do here, so I can get up both screens at once, we go ahead and type this in. So get that to go away for me. Oh, that's nice. Here, I'm going to flip this just a sec. Okay, so what we've got here is we got to do our 10 choose 4. Your calculator, that's under your probability menu. I've got mine right here. So NCR 10, 4, and we're going to take that times 1/6 to the 4th times 5/6 to the 6th. And if you can see right there, there's our probability, 0.05426. So, the thing is, once you have your formula written out, it is just a matter of typing this straight into your calculator. Not too much to do there, because obviously the formula takes care of it for us. Now, let's take a look at something like this. If we want to calculate the probability of rolling a dice 10 times and getting a 1 less than 4 of them, now we've got to do a little bit more work. So in this case, because we can't directly calculate the probability of getting a 1 less than 4 times, what we have to do is calculate the probability of getting a 1 0 times, getting a 1 1 time, getting a 1 2 times, and getting a 1 3 times, less than 4. So we have to find all of these things and just add them up. And so each time the formula is going to be the same. So here we'd have 10 choose 0 times 1/6 to the 0 times 5/6 to the 10. And that's just 5/6 to the 10th. Here we'd have 10 choose 1 times 1/6 to the 1st times 5/6 to the 9th. 10 choose 2 times 1/6 to the 2nd times 5/6 to the 8th. And the last one, 10 choose 3 times 1/6 to the 3rd times 5/6 to the 8th. And so we'll go through and we'll calculate what all of those are. And once we do that, we can simply add them all up. So I'm going to go back over here to Desmos. And I'm going to leave this in here. We'll just change these. So 10 choose 0 times 1/6 to the 0 times 5/6 to the 10. So right away, probably getting 0 1s is quite a bit higher, 0.16. And then let me see, can I copy and paste? Ooh, nice. So 9, change that to a 1, change that to a 1, up to 0.32 just for that one. Now we'll change this to a 2, 2, 8. See, our probability came back down now. Most common outcome was getting a 1 exactly 1 time. And then for the third one, for getting it a 1 3 times to the 3rd and to the 7th. And so we can go ahead and add all those up if we need to. So 0.16 plus 0.32 plus 0.29 plus 0.15. and we get about a 0.92 chance, or 92% chance, that if we roll a dice 10 times, we'll get a 1 less than 4 times. And that makes sense when you think about it, because getting a 1 will happen about 1 out of every 6 times. So the chance that it happens 4 out of 10, or almost half of the time, is going to be very, very low. But it does happen. Okay, last one I think we'll do together here, and this is where we get a little bit more interesting examples, are some of the things where we have some known probability of something happening, and then we can calculate what's the probability of hitting a certain number. So we have Steph Curry making 40% of the three-pointers he shoots, which is probably honestly a little low. What is the probability that he makes at least 8 of his next 10? And so again, in this case, we can't calculate this directly, but we have to calculate the probability of getting 8, the probability of getting 9, and the probability of getting 10 separately. And we'll just add those up once we do that. And so just like before, we're taking 10 shots, and we want to make 8 of them. And so we have 10 choose 8. Now we have our 40% chance of making it, so 40 to the 8th, and a 60% chance of not making it to the 2nd. Same thing here, 10 choose 9, all right, 0.4 to the 9th, times 0.6 to the 1st. And over here, 10 choose 10 times 0.4 to the 10th, times 0.6 to the 0. Now this does, again, just equal 0.4 to the 10th. 10 choose 10 is 1, 0.4 to the 10th, and then 0.6 to the 0 is just 1 as well. So calculating that probability of getting all 10 is actually much easier. So let's go ahead and put these into our calculator here. Go ahead and clear these out. And so again, start out with 10 choose 8 times 0.4 to the 8th times 0.6 squared. So right away, the probability that he makes 8 out of 10 is only about 1%. So we're assuming this is not going to be very high. And the probabilities for each of these going up is going to be lower. So the probability of getting 9, we're down to 0.015%, so basically 0.2%. And then we'll go ahead and type this in, the probability that makes all 10 is very small, 0.0001 on there. And so we've got basically 0.112 if we added all those up. So a very, very small chance. But again, this makes some sense. He only had a 40% chance of making the first one. Every single one after that gets slightly lower. And even by the time that he's making 8 out of 10, he's only doing that about 1% of the time. So the chance that he makes 8 of the next 10, 9 of the next 10, or 10 of the next 10 is going to be very, very low. Okay, so take a look here at the homework. Not too many to do, but what you'll see is you're going to use that probability formula to calculate these. A couple of notes here on these, I guess. When we are looking at a binomial experiment, one outcome is called a success and one outcome is called a failure. Don't think of that as good things and bad things. It's just the question that I'm asking you about is always going to be considered a success. And so if you look down here, we have these probability experiments where they don't even tell us what the successes and failures are. We just have a binomial experiment. The probability of success is 0.7, so that's your P of A. And we want to know what's the probability of getting exactly 3 successes. Well, we'd just be calculating, how many are we doing? 5 independent. So we're doing 5 choose 3, 0.7 to the 3 times 0.3 to the 2. So we use our formulas there. And then there's a bunch more that are actual applications. I will say this. Let's go ahead and do this. 3 through 14, there's no reason to do those all. Let's just do the odds on those. And I will see you tomorrow.